Hi hires. As usual, you'll be used to this with the lockdown videos. I'll post a starter ready for you. You attempt it and then I'll go over the answer. So we've got an equation here and I want you to calculate the delta H for the above equation using the equations below. Okay, so we've got three equations here, so you should instantly be thinking, right, this is a Hess's law question. So what I'll do, what I want you to do is pause this video, complete the starter, then I'm going to go over it. Okay, so pause it, complete it, and then unpause it. Right, so we've got our target equation, so the first thing we want to do is star that, and that's always the one that we don't have a delta H value for. Okay, now calculate delta H for the above equation using the equations below. So we start here and we say, we have a wee look, so we say, where do we see CHH6 about? Okay, so highlight that, and we see it in the third equation on the right hand side. So, does it have the same number of moles? Yes, it does. Is it on the same side of the equation? No, it isn't. Okay, so what we need to do to this full equation is we need to flip it or reverse it. Okay, so if we do that, we will get, so the C6H6 goes there, 6C plus 3H2 goes there, and the delta H, because we flipped it, we need to flip the sign, because because it's positive 49, this becomes negative 49. Okay, now once we've done that, we go on to the next one. Now it's oxygen, and remember what I said about oxygen, they sort of take care of themselves, so we can just move on to the next one. So carbon dioxide. Now where do we see carbon dioxide? We see it on the first equation. Okay, so is it on the same side? Yes, it is. They're both on the product side. Does it have the same number of moles? No, it doesn't. So what we need to do to the first equation is times it by 6. Yeah, and what you should get is 6C plus 6O2, and that goes to 6CO2. Yeah, and then the delta H, we also need to times by 6, so it's negative 394 times 6, and if I pop that in my calculator, we should be getting, hopefully, negative 2364. Yeah. Right, now we go on to the last one. So we have H2O. Okay, now where do we see H2O? We see it in the second. Now, is it on the same side? Yes, it is. Does it have the same number of moles? No, it doesn't. So what we have to do is the middle equation with times by 3. So it becomes 3H2, 3 times a half is 1.5, or 1.5, however you choose to write it, and that goes to 3H2O. Now delta H, because we've times it by 3, we need to times negative 286 by 3, and if I just put that on my calculator, so 286 times 3, that will be negative 858. Okay, now it's the fun part. If we've done this right, hopefully it should start cancelling out. Now what can cancel out? Well, let's have a wee look. The 3H2s can cancel out. Yeah, because they're the same on each side. The 6Cs can cancel out. Okay. Now, although they can't cancel out, these two can add up to 7.5. Okay, 6 add 1.5, 7.5. And what do we have left? Well, on the left side, if we just put the arrow, on the left side we have C6, H6, and that goes to 6 CO2 plus 3 H2O. Okay, and you should notice that is the exact same as the target equation. Yeah, beautiful. It's beautiful. So that's us. All we need to do now is add up all our delta H values. Now remember to add up these delta H values and not them. Okay, it's the new ones that we've sort of manipulated. So that's negative 49, add negative 2,364, add negative 858. Okay, and if we do that in our calculators, yeah, you might want to do this with me. That should be negative 3271 kilojoules per mole. Okay, so let me see, let me know how you get on. Just send a wee message on Teams, whether you got it or not. If you need help, need me to explain it, just message on Teams. Right, so what we're going to do now is we are going to move on to Unit 2. Now we were going to do oxidizing and reducing agents, but I would prefer to do that when I was in class, so we're going to jump straight to Unit 2. Now Mrs. Clark should have handed you your new Unit 2 active notes. It's the yellow cover. If she hasn't, can you just go to her class and ask for them, please? Right, anyway, so we're going to do a recap from Nat 5. Now obviously you guys never had an exam, so I'm going to make this a relatively straightforward recap, but I'm going to go into a wee bit of detail. So you learned of 5 homologous series in Nat 5, so the alkanes, alkenes, cyclo alkanes, alcohols and carboxylic acids. I'm going to give you a recap on each one. So alkanes, you should know, have the general formula, CnH2n plus 2. You should know that they are saturated, and what we mean by that is contains only carbon to carbon single bonds. Okay, and they do not decolorize. Bromine water. Okay, and that's because they're saturated. That's because we can't add anything over. Now, if we go to alkenes, they have the general formula CnH2n. Okay, it might be, sorry, I'll just say this now, whatever I'm writing here, I want you to write in your study tutorial jotter. Okay, at the front, whatever I write from now on, get in your study tutorial jotter. So alkenes, general formula CnH2n, they are unsaturated, and that's because they contain at least one carbon to carbon double bond. Okay, it's all from that 5 this, and because they do contain a carbon to carbon double bond, they can undergo addition reactions. So we'll say that, undergo addition reactions. So that's like your hydration, chlorination, hydration is the addition of water, hydrogenation is the addition of hydrogen, chlorination the addition of chlorine, bromination the addition of bromine, etc. Okay, so they do decolorize bromine water. Okay, next one, cyclo alkanes. They have the same general formula as alkenes, CnH2n. So if we have the same number of carbons in an alkene and a cycloalkane, they can be classified as isomers. Yeah. So they are saturated, and if they contain same number of carbons as an alkene, they would be isomers of each other. Okay, they will be isomers of each other. Okay. Right. Alcohols. They've got the general formula CnH2n plus 1OH. Okay. They can be used as fuels and solvents. So that's their uses. Yeah. They contain the hydroxyl group, and you still need to know that is the OH group. Okay. Right. Next one is your carboxylic acids. Okay, so they have the general formula CnH2n plus 1COOH. They contain the carboxyl group, which you should know is the COOH group. Yeah, the carboxyl group, the co group. Because they're acids, they have a pH less than 7. Okay. You should know again from that 5, ethanoic acid is commonly known as vinegar. Okay, so that's the sort of basis of what you learned at Nat 5. I'm going to go into a wee bit of recapping on how to name and how to draw each one. Okay, so I'll maybe do 2 examples for each, and I think that will probably be enough. Right, so new page. Alkenes. You can put the heading naming if you want. Yeah. So alkanes. Let's just go for this. Okay. Before we can sort of name, I guess you need to remember your prefixes. So meth, eth, prop, but, pent, hex, hept, and oct. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. Now I'm not teaching anything that you shouldn't already know here because this is purely Nat 5. Now for alkanes, what you have to do, you have to identify your longest chain. That's always rule number 1. Okay, so our longest chain in this case is 1, 2, 3, 4, and we always start from the side closest to the branch. Okay, so the branch is here. So we start on this carbon here. So that's carbon 1, carbon 2, carbon 3, carbon 4. Yeah. So to name this, because the longest chain is 4, so that's butane. Yeah, but meaning 4. It's an alkane, so it ends in ane, and then the branch is on carbon 2, so that is 2-methyl butane. Yeah, ile because it's a branch, meth because in that branch there's only one carbon. Okay. Right, next one. Let's go for a harder one. Right. So get this drawn into your jars. Right, so here we are. Now we've got to identify the longest chain. Now what a lot of folk do, they just go 1, 2, 3, 4, 5, 6, and they think the longest chain's 6, but it's not. The longest chain starts here. So it's 1, 2, 3, 4, 5, 6, 7. Yeah? Now, doesn't really matter what side we start from, because it would be 1, 3 and 5, 1, 2, 3, 4, 5, so it doesn't really matter what side. So we'll start here, so 1, 2, 3, 4, 5, 6 and 7. So our longest chain is actually 7. Now where are our branches? Well, we've got a branch there and we've got a branch here. Yeah. So if we start to name this, our longest chain is 7, so that is heptane, because it's still alkanes we're doing. Now we've got a branch, a methyl branch, yeah, so that's methyl, and that there is ethyl, because it contains 2 carbons in its branch. So we've got a methyl branch and we've got an ethyl branch. So, and remember, we always name the ethyl branch first, because ethyl in alphabetical order, E comes before M. So we name the ethyl branch first. So this becomes 5 ethyl, 3 methyl, heptane. Okay? And that's it. Right, let's go on to alkenes. Right, I'm only going to do, I'll very quickly do 2. I'll do this one, and I will do remember when drawing these, you can only ever have 4 bonds coming out of a carbon, because the valency of carbon's 4. So this here already has 1, 2, 3 bonds coming out it, so I can only put 1 hydrogen there. Yeah. Oh, wait there, sorry. Yeah, that carbon can only have 1, 2, 3, 4 bonds there, so I can't have a branch there. So instead, I'll put my branch here. Okay, so remember, just every carbon can only have 4 bonds coming out it. So let's start naming. Now, let's name this. We've got a carbon to carbon double bond. You always start, with alkanes, you start from the side closest to the branch. With everything else, you start from the side closest to the functional group. Okay, so the functional group is on the right side, so 1, 2, 3, 4. Okay, and because the carbon to carbon double bonds between carbons 1 and 2 we focus on the lowest number, which is 1. So this here is just called but 1 ene. Yeah? Nice and easy. Now, this one, yeah, again, it's the functional group that takes priority, so we ignore the branches and we start from the side closest to the functional group, which is the carbon-to-carbon double bond. So it's the left side, so this becomes carbon 1, 2, 3, 4, and 5. Yeah. So we have a branch on carbon 2 and carbon 4, and you'll notice it's the same branch. Yeah. So let's name the alkene. 5 carbons, so this is pent. It's between carbons 2 and 3. We take the lowest number, so this is pent 2 ene. And we've got a methyl branch. Yeah, we've got 2 of them, 1, 2. So we call this dimethyl, di meaning 2, tri would mean 3, tetra would mean 4, etc. Now, where are the branches? They're on carbon 2 and carbon 4, so this becomes 2, 4 dash dimethyl pent 2 ene. Okay, and again, this is all revision from that 5. I'm not teaching anything new here. Cyclo Alkanes I'll do very quickly. Sorry, I should have done that in a blue pen. So again, each carbon can only have 4 bonds coming out it. So each carbon in this case will have 2 hydrogen coming out it. Okay. Now it's a cyclo because it's in a ring structure. We would just call that, because there's 5 carbons, 1, 2, 3, 4, 5. This would just be called cyclopentane. Yeah, nice and hopefully nice and easy. Right. Right, I think I'll leave that. We'll just go straight on to alcohols now. Okay. Now, we're going to expand alcohols just a wee bit already. I know my class, we did branches at Nat 5 with alcohols, but you only really need to name branches when it comes to higher, so I will give you a few examples. So we'll start with an easy one. Okay, and again, we start from the side closest to the functional group, so that's our functional group here, the OH, the hydroxyl group, so that's carbon 1, 2, 3, okay, so because there's 3 carbons, that is prop, and because it's an alcohol, alcohols end in anol, okay, but because we've got more than 2 carbons, we need to name the position of the functional group, so this is prop an dash 1 dash ol. Okay, so this is propan 1ol. Now, if we go for this, let's just put the hydroxyl group there. And remember, with the hydroxyl group, it's so important that you have the carbon bonded to the O, because if you have it bonded to the H, you'll lose a mark. Okay, because it's bonded to the O, so just be careful. Be careful about that. I'm going to put a CH3 here. Right, so let's say, what side do we start from? Do we start from the left or do we start from the right? Now remember, we always take the priority of the functional group. Okay, which in this case is the hydroxyl group, so we start on the right side. So that's 1, carbon 2, carbon 3, 4 and 5. Okay, so because we've got 5 carbons, this will be pent an 2ol, because the OH is on carbon 2. Yeah. Now, because we've got a branch on carbon 4, and it contains only one carbon, okay, so it's methyl, and because it's on carbon 4, this becomes 4-methyl pentanetol. Yeah, so that's it. Yeah, we just need to know how to name branches with that. So I'll do 2 more. Let's go for so let's try and name this. So again, we start from the side closest to the functional group, which is our OH. So that would be the right side. So 1, 2, 3, 4. We've got branches on carbon 2, carbon 3, and also carbon 3. Okay, so they're all the same, which is why I've highlighted them the same colour. Yeah, they're all methyl. So let's name this. So name the alcohol part first. So there's 4 carbons, so that's bute. So that's butane. It's on carbon 2, so it becomes butan-2-ol. And we've got branches, we've got 3 methyl branches, so this becomes tri-methyl, yeah, tri meaning 3. And they are on carbons 2, 3 and 3, okay? So that's 2, 3, 3 dash trimethyl butan-2-ol. Okay, so 2, 3, 3 trimethyl butan-2-ol. Now, we're going to step up a wee bit. We're going to go sort of into the higher side of it. Now, we're going to see what happens when we have more than 2 hydroxyl groups. Which we've never done before. Okay, so again, we've got a hydroxyl group here, and we've got a hydroxyl group there. Start from the side it's closest to all the hydroxyl groups, which would have to be the right side. Yes, that's 1, 2, 3, and 4. Okay, we've got 4 carbons, so this is bute, so it's butane. And because we've got a functional group on 1 and a functional group on 3, this would be butane 1, 3. Yeah. Now, it usually ends in ol, but when we've got 2 of them, this would be di-ol. So this alcohol here is butane 1, 3 di-ol. Okay, so this here is your higher, part to it. Now I know I said that was going to be my last one, but I'll do one more. I'll do one with a branch. Let's just keep it. We'll keep it simple. Yeah, remember the carbon's bonded to the O, so this is HO as opposed to OH. Have a hydroxyl group there, and we'll have a branch here. Okay, so same idea. Highlight your OHs, which is there and there, and we've got a branch on carbon 2. So label it from the side closest to the functional groups. That's carbon 1, carbon 2, and carbon 3. Yeah. So we've got prop because there's 3 carbons, so it's propane. And because we've got a functional group, an OH on carbon 1 and carbon 2, this becomes propane 1, 2. And because there's 2 of them, it would be di-ol. If there was an OH there, that would be propane 1, 2, 3 triol. Yeah, which is commonly known as glycerol, but we'll come back onto that at a later time. Now, we've got a branch on carbon 2. There's only one carbon, so this is a methyl branch, and it's on carbon 2, so it's 2-methylpropan 1,2-diol. And that's it. Yeah, that's relatively simple. Now, the last thing we need to do is carboxylic acids. Okay. So let's put the heading carboxylic acids. And let's just name a basic carboxylic acid. Remember, it's got the carboxyl group, which is COOH, which if you draw it fully is C double bond OOH. Okay. Now, you should know that from that 5 that the carboxyl group is always carbon 1 because it can't go anywhere else. Yeah, it has to be at the end of the molecule, so that's carbon 1, 2, 3. So because there's 3 carbons, that becomes prop, and because it's a carboxylic acid, because it contains this carboxyl group, this is propanoic acid. Yeah, nice and easy. Now, the only step up there is that we can actually get branches. So let's just say we've got this molecule, we've got a wee branch there. So again, carbon 1 is always the carboxyl group carbon, so that's 1, 2, 3, 4. We've got a branch on carbon 3, so name the carboxylic acid first. So there's 4 carbons, so this is butanoic acid. Yeah, butanoic acid. And because the carbon's on carbon 3, there's only 1 carbon in there, so that's a methyl branch, so this is 3-methyl butanoic acid. Okay, I'll do one more. Let's make this, let's mix it up this time, so have it on the left side. Right, so again, we start with the carbon in the carboxyl group, so that's there, so that's carbon 1, 2, 3, 4, 5. Always check your branches just in case what looks like a branch might actually be the longest chain. So 1, 2, 3, 4, 5, it's the same, so it doesn't actually matter in this case. So our branch is, we'll do it a different colour, is C2H3, so that's an ethyl branch. Okay, so longest chain is 5, so that's pent. It's a carboxylic acid, so it's pentanoic acid, and because we've got an ethyl branch on carbon 3, this becomes 3-ethyl pentanoic acid, and that's it. Yeah, it's all about practice. In fact, you know what? I said I was going to do. Let's do one more, because why not? Can never do too many of these. Let's change that to a CH3 actually, just make it a wee bit more challenging. Okay, so you're not going to get really much harder on this if I'm being honest. But anyway, name your longest chain. Your carbon 1 is always your carboxyl group carbon, so that's 1, 2, 3, 4. Now be careful, okay, because our longest chain wouldn't be 5. Our longest chain here would be 5, 6. Okay, and this is what the SQA will do. They'll maybe fling in a trick one, because, well, we know about the SQA, they're horrible people, they're trying to trick you, they're trying to yeah, trying to get you to make mistakes, and we don't want that, okay? So be careful, identify your longest chain. So we have a branch here, we have a branch here, and we have a branch here, okay? Now they're all the same type of branch, they're all containing one carbon, so they're all methyl branch, but name your carboxylic acid part first. So that's 6 carbons, so that is hexanoic acid, and it's methyl, and because you've got 3 of them, yeah, 1, 2, 3, this is tri-methyl, and they're on carbons 2, 3 and 4. So this is 2, 3, 4 dash trimethyl hexanoic acid. Okay, and I think that will be it for today. So sort of main points that you guys need to know is how to name each sort of homologous series: carboxylic acids, alcohols, cycloalkanes, alkenes and alkanes. But you also need to know this part, okay? You need to know your general formula for each one. There's no excuse, okay? You need to know about the whole saturated, unsaturated thing. You need to know about isomers, okay? We could maybe make a wee note here, just for anyone that's perhaps forgotten the definition of an isomer. So it's molecules with the same molecular formula but different structural formulae. Okay, and trust me, you will get an isomer question in a higher paper. They like to chuck one in. Okay, right, I'm going to put up some work for you to do on Teams, so make sure you take all that in, you understand it, and then you're going to work out your active notes. I'll put up what questions I want you to do. Okay, right, thank you.